Here we're going to factor polynomials and use the factored form to find the zeros, then sketch the graphs. P of x equals x cubed minus 5x squared minus 24x is our first polynomial. It factors taking out the common factor of x into x times x squared minus 5x minus 24. The quadratic then factors. I'm going to factor it by trial and error. I'm looking for two numbers that multiply to be negative 24 and add to be negative 5. Negative 8 and positive 3 will work. So x minus 8 times x plus 3. So the zeros are x equals 0, x equals 8, and x equals negative 3. Now we also notice that the leading coefficient is 1x cubed. And so the end behavior is going to parallel that we see for y equals x. And so looking at the number line, we have to order our zeros from smallest to largest: negative 3, 0, and 8. And the graph will be coming from below the x-axis to the smallest x-intercept, return down to the x-axis at x equals 0, go below the x-axis until it gets to x equals 8, and then beyond the largest x-intercept continue to increase. So it will have one local maximum, one local minimum. No statement is being made as far as how far away from the x-axis the graph gets at that maximum or minimum value. The second polynomial has a common factor of x squared. So it is x to the fourth minus 3x cubed plus 2x squared. When I factor out the x squared term, I'm left with x squared minus 3x plus 2. The polynomial, or the quadratic factors, looking for two numbers that multiply to be plus 2 and add to be negative 3. So minus 2 and minus 1. The zeros are x equals 0, x equals 2, and x equals 1. It's important to note that x equals 0 has multiplicity of 2 factors of x. That means the graph is going to be tangent to the x-axis at x equals 0. It's going to bounce off. Because the leading coefficient is 1x to the fourth, the graph is going to have end behavior the same as 1x squared. And so the graph will come down from above to the smallest of the x-intercepts. So we have 0, 1, and 2. So it's going to come down from above, bounce off the axis at x equals 0, come back through x equals 1, then come up and increase for values of x larger than the largest x-intercept. So the graph will look something like this. In this case, 2 local minimums, 1 local maximum. The third example has 4 terms, x cubed plus 4x squared minus 16x minus 24. And we're going to graph this using factoring by grouping. You may want to review that. In order to use factoring by grouping, I change the subtraction of 16x to add a negative. Then we're going to have 2 factors, x cubed plus 4x squared plus negative 16x. And I'm going to write that as plus negative 64 as well. So from the first group, I can factor out an x squared. From the second, I'm going to factor out a negative 16. That leaves me with x plus 4. X plus 4 is a factor in both of these terms. So I factor out the x plus 4. That leaves me with x squared minus 16, which can be factored as x plus 4 times x plus 4 times x minus 4. So in this case, we have 2 factors of x plus 4, which gives us that x equals negative 4 is a factor with multiplicity 2. We also have a factor of x minus 4, which gives us a 0 of 4. Because the leading coefficient is 1x cubed, the end behavior will be similar to y equals x. I locate the points on the x-axis for the x-intercepts. Negative 4 and 4. The curve is going to come up to the x-axis to the smallest x-intercept, which has multiplicity 2, so it's going to be tangent to the x-axis at negative 4. It's going to bounce off, go back down below the x-axis, and finally cross through the x-axis at 4. So the behavior is going to be like so. A local maximum and a local minimum in this case. Our next function is p of x equals x to the fourth minus 15x squared minus 16. Remember that we have studied functions that are quadratic in form. So this is an example of that type of factorization. We are going to let w equal x squared, and notice that if we substitute w for x squared, x to the fourth will be w squared, x squared squared, minus 15w minus 16. This factors as w minus 16 times w plus 1. I'm sorry, that should have been a w. Now we're going to back substitute x squared 4w. We're going to get x squared minus 16 times x squared plus 1. The x squared plus 1 does not factor in the real numbers, but x squared minus 16 gives us an x plus 4 times x minus 4. So the only two real zeros this time are x equals negative 4 and x equals 4. The leading coefficient was x to the fourth, 1x to the fourth, so the end behavior is going to be the same as x squared, y equals x squared. Now, as I draw this graph, I'm going to ignore the x squared plus 1. However, that may cause extra wobbles in the graph, if you like. I'm going to concentrate on negative 4 and positive 4 as being zeros, as well as the end behavior. So we're going to come from above the smallest of the x-intercepts, cross over, and go back through the other x-intercept. Y will be above the x-axis for x larger than the largest intercept. Now, my suspicion is that there are wobbles in this graph because of x squared plus 1, but right now let's focus on the intercepts and the fact that the graph starts above the x-axis, goes below, and then ends up above the x-axis. In the last example, x to the sixth minus 16x cubed plus 64, let w equal x cubed. And I'm not going to have time to finish that in this slide. I will finish it in the next video.